For these problems, we're going to be looking at the order of the equations. So for this first one, and for any one actually, when we look at order, we're going to be looking at how many times we need to differentiate this. One of the two, I keep forgetting the actual term, but basically we have this y double prime. Notice how this y is really like y to the 1. And if this y was like a y cubed, would this still be a second order, or would it be a third order? Well, it would still be a second order because we only care about this, what we are deriving. Now, it comes to a point where if we have this 3 up here, but it's in parentheses, it's going to be a different answer. Because if it's in parentheses, that means that essentially it's equivalent to this. Obviously it's a different number, but that's what it means. So like if we had a 2 in here, and then in parentheses, this would be equal to each other. Now for this, we have an exponent of 1 right here, and then we have this double prime. And since it's a double prime, that means the order for this first one is going to be 2, because of this first part right here. For the next one, what is the order of the following equation? Well, here we have a y triple prime, we have a y double prime, and we have a y prime. And we only care about the things that are being primed. We don't care about the other constants, like this would be a constant and this would be a constant. So looking at this, we can see that the larger is the y triple prime. So our answer here is going to be 3. The order is 3. We always care about the highest one. Next, what is the order of the following equation? So for the following equation on this one, we can see that we have this 3 right here. Now, it's not in parentheses. If it was in parentheses like this, we would have a third order. However, it's not in parentheses, so this is just a exponent, not a prime. So that means we have this double prime right here. So we have a z double prime, and that means that our order is going to be 2. And that's how we would look at and solve this problem in anything like it. This is a good example where we have a lot going on here. So we can see that this t cubed is just a constant, and I'm just going to put c, and it's going to have some exponent on top of it. Now this one, it's going to be our x with a prime, so we're going to want to look out for this. It's a prime of 2. Now this x to the 4 is what we've talked about a lot, where we have an exponent but there's parentheses around it, and if there's parentheses around it, this means it's a prime. Just like our 2, it's going to be a prime of 4. And this x right here is just going to be an x with an exponent, not a prime. So again, this is an exponent with a prime. We have to compare our two primes. We can see that this one is smaller than this one. So this is going to be our order. And so the order is going to be 4 for this problem.